Guys, in this video, let us look at what epidemic and epidemic curve is, what are the types of epidemic, right? There are so many types of epidemics, right? We need to look at all these in this video, okay? So first of all, let us start off with what epidemic is. So epidemic is the occurrence, okay, of an illness, right? Or any health related event in excess of the normal expectancy. So you're understanding, right? So basically, occurrence of what? Of illness or some health related events, okay? We'll leave that part. Clearly, it is in excess. It is in excess of normal expectancy. So you will expect something, but it is normal, more than that. It is in excess of that. So this is epidemic, okay? So now you will get a doubt. What do you say is normal, right? So normal expectancy, how will you define? So you will look at the average number of cases, right? You will look at what? You will look at the average number of cases in that geographical area, right? In that geographical area, right? In the last 3 to 5 years. So you will see the average number of cases in that area in the last 3 to 5 years. You will know what normal expectancy is. So if normal expectancy is 0, then what do you do? If normal expectancy is 0, then even if one case is there, it becomes an epidemic, okay? Even one case is called an epidemic. Interesting, right? So even one case becomes an epidemic. So you have understood what normal expectancy is, what epidemic is. Even if one case is there in a normal expectancy 0 area, then it becomes an epidemic, okay? Statistically, they are saying that epidemic is when number of cases is greater than mean plus 2 standard deviations, okay? So basically, statistically, if you have to define, epidemic is when number of cases greater than mean, okay, plus 2 standard deviation. So if the number of cases is greater than mean plus 2 standard deviations, then this will be called as epidemic. Epidemic, there's one more definition here. Epidemic is also occurrence of new disease, right? Or recurrence of an eliminated or eradicated disease. That means NE is 0. So when can NE be 0? Sometimes NE is 0 if the disease has not occurred there. That means it's going to be a new disease now, right there. Or it's an eliminated or an eradicated disease. Then it will become, even if one case is there, it becomes an epidemic, okay? If NE is 0, that means a new disease is, they are telling, or it is eradicated, or it is eliminated, right? Even if one case is there, it becomes an epidemic. So, is this clear? So, basic definition of epidemic, when you call it epidemic, everything is clear. Okay, now let us go to some epidemic curve. So, now let us look at epidemic curve. Okay. So, before going to this epidemic curve, let us look at some examples also, okay? Like food poisoning can be an epidemic. Food poisoning can be an epidemic. Food poisoning, cholera, caused by Vibrio cholerae bacteria, right? Measles, hepatitis A, all these can be epidemics, okay? So, is this clear? So, all these can be epidemics. See, epidemic is where you're talking about a particular geographical area, okay? So, basically, you're talking about a particular area, okay? But pandemic means what? Pandemic means the entire continent or country or world is involved, okay? So, pandemic involves a larger area. So, this is what, when you Google for epidemic, this is the kind of photo you get, okay? Now, let us look at epidemic curve. Okay, so there are actually many types of curves here. Anyways, look at epidemic curve. It is a graphical representation of time distribution of epidemic cases. So, what is this epidemic curve? So, it is a graphical representation of what? Of the time distribution. Okay, time distribution of the cases. Okay, so we are concentrating only on that disease. That disease has become epidemic. Only that cases, the cases of that disease, you will graphically represent against time. Okay. So, this, by looking at this graph, you will be able to say the onset of the epidemic, when this epidemic came, right? When did this epidemic start? For how long was it there? What is the duration of this epidemic? How the cases started increasing? When did they reach a peak? How long was this peak maintained? Right? And how did the epidemic start declining? When did it reach an endemic level? From epidemic, when did it become endemic? Okay, from epidemic, when did it become endemic? So you understood what graph is, right? Epidemic curve. What is an epidemic curve? You have understood. So basically what and all it will show? It will show when did the epidemic start, what was the duration, how did the cases start increasing, when did it peak, how long was the peak maintained, when did it start declining, when did the epidemic become an endemic. Okay. So all this you will be able to see in the graph, in the curve. Epidemic curve we have finished. Now let us look at the types of epidemics. Okay. Types of epidemics, you have common source epidemics and propagated epidemics. So here whatever you are seeing, the first two graphs, these are common source epidemics and this one is propagated epidemics. Okay. So can you tell the two types of epidemics, mainly broad classification?
Common source, propagated.
That's right, common source and propagated. Okay. So people, now let us look at what exactly common source is. Okay. So pretty clear only it is, the name itself, common source. Right. Under common source you have two things here, single exposure and repeated exposure. What and all you have? Single exposure and repeated exposure. What is the other kind here, guys? It is propagated epidemic. Okay, propagated epidemic. So now let us look at common source. What do you say? So basically in common source what happens? There is a point source. Okay. So one source, right? So probably people go and eat in one place, right? And all the people who ate in that place are affected. So this will be common source, single exposure. So the best example for this will be food poisoning. Food poisoning, okay. Food poisoning will be a single exposure epidemic, okay. Common source, single exposure epidemic. Now let us say repeated exposure. Repeated exposure or multiple exposure, right? But the source is single. The source is single, but multiple times people are exposed. That is cholera. Okay. So that becomes a common source again. So the source is common in cholera, but repeated exposure. Probably you are drinking water from a well. Repeated exposure to that source. This is completely personal understanding of what they are telling here. Guys, you will have to read the textbook for more details. Propagated. Now what is propagated epidemic? So shall we go to propagated epidemic? So we are moving on to which one now? We are moving on to propagated. Okay. So we are going to propagated now. Here guys, in propagated you have it is propagating person to person or via an arthropod vector or animal reservoir. Person to person guys, person to person like polio, measles, okay. So what can you think about an arthropod vector like plague, like rats can transmit, right? Rat fleas, plague, right? Animal reservoir which can come from animals, you have Ebola. So these examples of propagated epidemics. So let's add these examples here to our first slide. So we said food poisoning, cholera. Now let us say add polio, measles, plague, Ebola, right? So basically food poisoning you saw in common source, single exposure. Cholera you saw common source, multiple exposure. Polio you have seen in from here. From polio you are saying it is propagated epidemics. So you have polio, measles as person to person transmission. Plague is arthropod vector propagated epidemics. Then you have Ebola which is propagated via animal reservoir, right? So all that you should write here. Then we have yet another type of epidemic guys, that is called as slow or modern epidemic. So which one? We are talking about slow or modern epidemic. So here you have things like diabetes, and hypertension. So these cases are like more than the normal expectancy. So they are saying if there can be diabetes or hypertension is more than the normal expectancy, so it becomes an epidemic. So it is a modern epidemic nowadays. Everybody will have this kind of diabetes, hypertension. So it is a slow or modern epidemic. So let's try to understand this. Slow, modern, epidemic, epidemic, diabetes, hypertension. Oh. So people, you understood, right? There are 3 types of epidemics now. What and all, we added one more type, right? So you will say common source epidemics, propagated epidemics, and slow or modern epidemics. Okay? Common source epidemics, propagated epidemics, slow or modern epidemics. Okay? Good. So listen and learn.
Common source epidemics, propagated epidemics, slow or modern epidemics.
Thank you. Okay. So now look at the graphs. Are you able to understand? So this is a common source single exposure epidemic. This one is a common source continuous or repeated exposure epidemic. Then there's a graph here for propagated epidemics. Okay. Propagated epidemics. Okay. So guys, according to this book here, food poisoning, cholera and all are common source. Polio, measles, plague, Ebola and hepatitis A, all these are propagated. Then you have diabetes and hypertension, which are slow or modern epidemics. So we have put all the examples here. So now let us go to details about each of these and quickly finish off. Don't worry, we won't take much time. Common source single exposure. So basically here the population is exposed to the disease agent briefly and simultaneously. So all the people will get food poisoning, right? So there's a single peak, there is rapid rise, rapid fall, there's no secondary wave, correct? So this is food poisoning. It's also called as point source epidemic. So even Bhopal gas tragedy was like that. A single exposure killed so many people, right? Just over a night. Okay. So basically this results from exposure to infectious agent, right? Like food poisoning or even to environmental contamination, pollution, the poisonous gas which happened in Bhopal gas tragedy, which is really sad. If you read the history, you will know. Bhopal gas tragedy is really sad incident. Bhopal gas tragedy can be an example, they are saying, of a point, they are calling this as point source epidemic. Common source is point source only, right? Why would you call it like this? Point source epidemic, right? So basically, here what is happening in common source? This one, guys, common source single exposure. If the epidemic continues more than one incubation period, it will be multiple or propagated epidemic. So here there is only single exposure, single source, right? So here it is not having more than one incubation period. Okay. These epidemics are explosive. There is a clustering of cases with a narrow time interval. All the cases develop within one incubation period. That's nice. So it's not nice, but yeah, we're just saying. It's pretty clear here. One incubation period only. There's only one incubation period, right? Then there was some other term here. It is explosive. The cases are like explosive. Suddenly they'll come, suddenly they'll go. Okay, there is clustering of cases. Narrow time interval, right? Then, what else, guys? There was rapid single peak. There is a single peak, rapid rise and rapid fall, okay, of the graph. There is no secondary wave. No secondary wave. It's pretty clear, right? What do you think? So, are you seeing any secondary wave here? So, there is a single peak, there is rapid rise, rapid fall, it's explosive, there's a clustering of cases, narrow time interval. So, it's pretty clear, right? So, this one is done. We are done with this. Guys, how is it going? We are done with what? Common source, single exposure. Okay. So, now let us move on to common source, repeated exposure or continuous exposure. Okay. So, now we are moving on to which one? This one, repeated exposure. Common source, repeated exposure. We are going to this one now. So, the graph, you look at the graph here, this is common source, continuous or repeated exposure. Okay. So, let us look at this one now. Fine, guys, are you okay? Let us look at this one. Common source, continuous or repeated exposure. So, here, the population is exposed to the same source continuously, repeatedly or intermittently. Epidemic peak shows sharp peak but gradual tapering over long period of time. So, there is a sharp peak but there is gradual tapering over long period of time. So, here you can see a peak is there but the tapering is over a long period of time. These epidemics tend to be more extended or irregular. So, these are extended epidemics, they are irregular. It continues beyond the range of one incubation period. Obviously, here we already told you that in one incubation period is there only in single exposure. Okay. Anything more than that will be in some other category. So, repeated exposure, there will be more than one incubation period. The epidemic tends to be extended, irregular. There is a sharp peak but there is gradual tapering over time. So, now let us move on to the last one here, guys. We are almost done with this video. Don't worry. How's it going? So, let us move on to propagated epidemics now. So, what is this? Propagated epidemics. Now, we are moving on to this one. Okay. So, we are moving on to propagated epidemic. So, this one, propagated epidemic. Is it clear for you, the color? How about this color? Propagated epidemic. Now, we are looking at propagated epidemic. So, here you can see propagated epidemic shown here. So, basically, the population is exposed to an infectious agent which transmits from person to person through direct contact or through a vector, right? Think about measles, right? Think about measles, it will be easy to understand. It is propagated from person to person. Such transmission continues till there are susceptible individuals in this population. It will keep continuing. Such individuals are exposed to the infectious agent, okay? Where whoever are susceptible and they are exposed to this infectious agent, they will continue to transmit the disease, get the disease, etc. Okay? Wait. Here, guys, what happens? There will be in propagated, basically, there will be a slow rise. You can see here in the graph, there is a slow rise, correct? Gradual rise, tails off over much longer period of time. To tail off, it will take a long period of time, okay? The speed of propagation is determined by herd immunity. So, if herd immunity is less, the propagation will be fast. So, the speed of propagation here depends on the herd immunity. So, let's write that here. The speed of transmission depends on herd immunity. And basically, whenever there is susceptible people, right, then this will keep propagating. Susceptible individuals, if they are there, then it will keep moving, okay. So, we are done with propagated, right? So, here there can be secondary attack also. There can be a secondary attack rate. Secondary attack rate, okay. So, then you have slow or modern epidemics. There is no graph given in this book. So, we are done with these three types. How's it going, people? So we finished 3 graphs, right? So is it fine? Now let us look at the applications of all this information. What will we look at now?
Application.
Yes, application of all this information. So what will you apply all this for? Applications, okay. So to study the time relationship with exposure to suspected source. So you want to study this time relationship with exposure to suspected source. You want to study some time relationship. Okay, and all that. Then to know whether it is common source or propagated epidemic. So you want to know whether it is a common source or a propagated epidemic. You want to know the type of epidemic. Find out the type of epidemic based on cyclic or seasonal pattern of a particular infection. So you want to know whether there is some cyclic or seasonal pattern, right, of a particular infection. You want to know if there is some cyclic or seasonal pattern. Then lastly, they are saying significance of this. Let us finish off with the significance. This is how you will write in the exam. You'll have to put these headings, significance, each one you will have to write one point next to it. Always end with some significance. Significance, it is easy method of analyzing and understanding an epidemic. As simple as that. It is an easy method to analyze and understand an epidemic. Okay. It's fine now, guys. So in this video, we have completed epidemic. We have looked at the epidemic curve. We have looked at what epidemic is. We have looked at what normal expectancy is. We have looked at the examples, right? Then we have looked at the epidemic curve, what exactly it is, what are the types of epidemics and their particular graphs we have looked at. We have looked at the applications of these graphs. We have looked at the significance of these graphs. And that's all in this video. We will meet you in the next video. Bye-bye.
Bye.
Bye.